Okay, Eg10. A mass of 0.5 kilos is resting on a rough plane. The coefficient of friction between the mass and the plane is 1 over root 2, and the plane is inclined at an angle of theta to the horizontal, such that sine theta is 1/3. A mass then experiences a force of 6 newtons applied up the plane along the line of greatest slope. Calculate the magnitude of the acceleration of the mass up the slope. Okie doke. So we've got an inclined plane at an angle of theta. We've got the mass on the plane. G, we're going to have a normal reaction there. And this time, if it's going to move up the slope. So we're going to have a frictional force there. It's going to cause it to accelerate in that direction. The force that's going to cause it to go up the slope is 6 newtons. So I'm going to take my plus x to be parallel and up, and my plus y to be perpendicular and up. That's theta, and they're telling me that sine theta is 1/3. Which is opposite over hypotenuse. So this side is going to be 3 squared, take away 1 squared, equals root 8. So if that's root 8, cos theta, should we need it, is going to be a over h, which is root 8 over 3. So that's just Pythagoras to work out what that adjacent side is. It's a shorter side, so it's the difference between the two squares. Square rooted is 8. Cos of theta is adjacent over hypotenuse, so that's root 8 over 3. Right, let's produce our equations then. So it's going to accelerate up the plane. So we're going to have Newton's second law being applied in the parallel to the plane direction. So I've got the 6n, so 6 minus f minus 0.5 g sine theta. Yeah, this is the inclined bit. This is where it's opposite to normal, and the horizontal component, or perpendicular, the parallel component, is sine, and that's going to equal the mass times the acceleration. So that's my first equation. Perpendicular to the plane, there's no acceleration. It's in equilibrium, so the sum of these forces are going to equal y equals 0, and that's going to be n minus 0.5 g cos theta equals 0, and then the last expression is the f max equals mu, which we know is 1 over root 2 times the normal reaction. We want to find the acceleration of the mass up the slope. So the acceleration is going to come from equation 1. In order to use equation 1, I need to eliminate f. In order to eliminate f, I need n. So I'm going to rearrange 2, put it into 3, and from there into 1. So from 2, the normal reaction is 0.5 g cos theta, and I know the cos theta is root 8 over 3, so n is 0.5 g root 8 over 3. Put that in 3, and the maximum f, which we're just calling f now, equals 1 over root 2 times 0.5 g root 8 over 3. Let's see if we can get a neater version of that. So fraction 0.5 a root 8 3 root 2. So that works out to be 49 over 15. It's a little bit easier to use than all of that. So now we're going to work in 1. So in 1 I want the a, so I'll have 0.5a equals 6 minus f, which is 49/15, minus 0.5 g sine theta, which is a third. So a is going to be all of that divided by 0.5. So 6 minus 49/15 minus 0.5 a over 3. So 6 minus 49 over 15 minus 0.5 g over 3 equals 1.1 divided by 0.5, 2.2. And that's already two significant figures, so that's good to leave where it is.